Welcome to Chapter 4, Section 2 on ionic compounds. Chemical bonds can be defined as ionic compounds or ionic bonds or covalent bonds. The first bonding that we're going to talk about is ionic bonds and ionic compounds, which make up ionic compounds. Ionic compounds consist of positive and negative ions, usually a metal and a nonmetal, and the attraction called ionic bond is between the positively and negatively charged ions. So if you remember from the previous video, metals form positive charges so metals, which how about as a M here, form positive charge, and non-metal, represented as N, form negative charges. Okay, and so if you think about a magnet here, for instance, if you have the negative and the negative end toward each other, or the positive and the positive end of two magnets toward each other, they're going to repel. Okay, however, if you have opposite charges, you have a positive and a negative charge, they're going to attract. So you can kind of think of this as opposites attract, opposite charges attract, and that's what's going on here. And this is actually a very strong bond because you have this electrostatic positive and negative charge. And this results in compounds that have high melting points. A lot of times they are crystal solids, and the reason they have high melting points is because they have strong bonds. They have these strong interaction between them. And they are also solids at room temperature. And so ionic compounds usually consist of a metal and a nonmetal because they have a positive and a negative charge, and they're going to actually transfer electrons. So ionic compounds or ionic bonds involve the transfer of electrons. So we think about table salt. So everybody has used this before, and sodium metal just by itself is actually a shiny and soft metal, okay? And chlorine is a yellowish green poisonous gas by itself, not bonded to a metal. So when sodium and chlorine combine, they form table salt. And so the physical and the chemical properties of an ionic compound, such as NaCl, or table salt, are very different from their original form, or their original elements. And so they form sodium chloride, and here we can see it's kind of this crystal solid, and with Na plus 1, we'll talk about that in a minute, but remember sodium's in group 1, it forms a plus 1 charge, and chlorine's in group 7, and so it forms a negative 1 charge. And so these are the ions represented. For your ionic formula, it consists of positively and negatively charged ions. However, these charges have to be neutral. Okay, they have to balance each other. So your total positive charge is going to come from your metal has to equal the total negative charge that comes from your nonmetal. Okay, and when you write these out, you write the metal symbol first, and then you write the nonmetal symbol. Okay, so this kind of explains ionic bond a little bit better here. So we have magnesium, which is a metal. So if you have to pause and go look at your periodic table to convince yourself of that, you can. It's in group 2, so it's a group 2A metal. Chlorine is in group 7A, and our metal wants to lose 2 electrons, and our chlorine wants to gain 1 electron. Okay, so if we were to combine magnesium and chlorine, okay, they're going to have to combine in a ratio so that they complete their octet. Okay, and so magnesium wants to lose, so it wants to lose 2 electrons. Therefore, we have to have 2 chlorine atoms that can accept these electrons. Okay, one chlorine atom wouldn't do the trick because it only wants to accept 1. It doesn't want to accept 2. Okay, and so we have to donate 1 electron here and 1 here. Okay, and so our formula, so here's our ion, so we have a 2+ charge, and now we have a -1 and a -1 charge. So once again, our charges have to balance. Okay, we have 1 magnesium atom that has a 2+ charge. Okay, so the 1 is the number of atoms, and the 2+ is our ionic charge. But we have to have 2 chlorine atoms with a -1, or chloride ions, with a -1 charge in order for our total charge to equal 0. Okay, so when we write this out to show the number of atoms, then we write out Mg, an understood 1 there, Cl2. So for every 1 magnesium, we have to have 2 chlorine atoms in order for our charge to balance. The subscripts in our formulas indicate the number of atoms. Okay, and so we wrote on the previous slide MgCl2. And these subscripts here, these indicate or represent the number of positive or negative ions. Okay, and so we have 2 chlorines for every 1 magnesium. That's because we've just seen that our total positive charge has to equal our total negative charge, or the 2 added together has to equal 0. So we're going to show this one more time. So magnesium's in group 2, so it has a 2+ charge, and we have 1. Our chlorine, we have 2 chlorine atoms that has an ionic charge of -1, because chlorine wants to gain 1 electron, and so 2 minus 2 equals 0. And so this is the way magnesium chloride combines. And it's not just a coincidence. It is because of the octet rule and the fact that your total charge has to balance and equal 0. Okay, so this is just basically another problem to practice. Okay, if we were going to combine sodium and sulfur, okay, so you can go through and look here. I'm going to kind of go off to the side and show this. So we have sodium and sulfur. Okay. If we find sodium on our periodic table, we see that it is a metal and it has a +1 charge, ionic charge, because it's in group 1. Okay. For sulfur, it's in group 6. So it needs 2 more. It needs to gain 2 electrons to have a stable octet. And so it has a 2- ionic charge. Okay, and so how are these going to combine? What's our formula going to look like? Okay, and so if we look here, all we know is that we have a +1 charge, and we have a -2 charge. And we know that these have to equal 0. Okay, and so if we fill in for the number of atoms, okay, so how many atoms are we going to need of each? Okay, so we have to have our balances have got to be 0. Okay, and so we're going to need 2 sodium atoms for every 1 of our sulfur. Okay, because 2 minus 2 equals 0. So we need 2 sodiums, and so when we write this formula out, we would say Na2S. Okay, in order when sodium and sulfur combine, they're going to combine in a way that sodium, we have 2 sodiums for every 1 sulfur. Okay, and so we can see this, the big picture here. We have sodium, which has this 1 valence electron, okay, and we have sulfur that has 6. So it has 6 valence electrons, and we have 1 valence electron. Okay. The sulfur wants to gain 2. Okay, so if we just have 1, that's why our formula is not NaS, because if it just gains 1, then sulfur only has 7. But it doesn't want 7, it wants 8 to complete its octet. And so another sodium atom has to be involved for it to gain an electron. And once again, we're transferring electrons. That's what an ionic bond is. And so we need 2 sodium ions for every 1 sulfur. And so when we look at the charge balance here, which we did on the previous slide, we need 2 sulfurs because we have a +1 charge for every 2 sodiums for every 1 sulfur. And we write our formula as so. Okay, we're going to charge balance for sodium and nitrogen. So if we combine sodium and nitrogen, what is our formula going to look like? Okay, and so what we're going to do here, so we've got Na plus, we have nitrogen. Okay, I want you guys to find nitrogen on your periodic table. It's in group 5. Okay, so how many electrons does it need to gain to be like neon, to be like the nearest noble gas? Exactly, it needs to gain 3. Okay, so it's going to have a 3 minus charge. Okay, so now we want to look at what's our formula going to look like. What are our subscripts? Okay, all right, so we have 1 sodium, okay, represented here. We have a +1 charge, excuse me. Okay, we're trying to find this here. Okay, and we have a -3 ionic charge for nitrogen. Okay, and so our charges have to balance. We have a -3 and we have a +1. Okay, so the only way that we can balance our charge is if we have 3 sodium ions for every 1 nitrogen ion. Okay, and so we write our formula as Na3. This represents the number of atoms in, and we don't have to write a 1 here. Okay, you can if you want to, but it's understood that there's 1 atom. Okay, now I want you to write the ionic formula of the compound formed when barium and chloride ion form an ionic bond. Okay, go ahead and show this here. So we have barium 2+. We get that 2 from the periodic table because it is in group 2 and it's a metal, so it has a positive charge. We have chloride, which is in group 7, so it just wants to gain 1 electron to be like argon, so it has a -1 charge. Okay, now we want to write the formula. So how can we balance our charges? So we've got a 2+ charge. Okay, and we don't know how many atoms we're going to have of each here. And we have a -1 charge. And we know that the total charge has to equal 0. Okay, so the only way it looks like to me, the simplest way to make this equal 0 is if we have 1 barium for every 2. Let me erase this real quick. For every 2 chloride ions. So now we have 2 minus 2 equals 0. So we have 1 barium, so it has an understood subscript there, and we have 2 chlorine atoms. Okay, so this is why when you react barium and chloride, they're going to form BaCl2. They don't form Ba2Cl or Ba3Cl or any of the other arrangements. They form BaCl2, barium chloride, so that they have a stable octet and their charge is balanced.